Hello, everyone. My name is Shamser Ahmed. I'm a senior HPCC platform developer. Today, I'll be providing an update on recent developments and sharing medium-term plans for the Workunit Analysis Tool. Before we begin, I'd like to start with a quick poll. How useful would a post-execution Workunit analyzer be for you? Very useful, useful, not useful, not sure. You should see the poll question at the bottom of the presentation. The results will go over at the end of the presentation. Today, I'll be discussing, so for people who haven't come across the Workunit Analyzer before, the Workunit Analyzer is a post-execution analyzer designed to highlight suspected issues with ETL jobs, issues that is affecting performance, execution time, etc. The first release was October 2019 as part of 7.6. In that release, the tool identified many related issues. You can see from the screenshot some analysis produced by the analyzer. It provided a cost value for every issue, the cost being the time penalty caused by the issue. We also provided a command line version, which may be useful in updating analysis or integrating with some third-party software. If you're interested in more technical and background information, you can find it in my blog, which I published back in February. It's on the HPCC Systems.com. Just search for my name. So today, I'll be discussing the recent developments and plans for the future. These are the areas I'll be covering in the talk. The latest developments, the development plans covering the time period into 2021, and I'll be briefly touching on our longer-term plans. So since the first version was released in October 2019, we have made some improvements and fixes. The analyzer now provides the file name and line number of each reported issue. In the first release, we provided the activity ID most closely associated with the issue, but it was a little bit cumbersome to track down the relevant ETL from the activity ID. We've also improved the formatting of the cost to make it more human readable. That's only in the command line version because at the moment that's where the cost can be viewed. We're looking at having the cost shown in ETL Watch as well. So the other thing we've done is we've extended the command line version to be able to update the analysis saved with the Workunit. So if you have a job with analysis recorded with the older version, you can use the command line version to update that analysis with the current, most up-to-date analysis. Okay, we've made some fixes in the statistics. We found some things that were affecting how well the Workunit Analysis Tool was providing analysis. For example, we didn't have any statistic for the time node sent blocked. That is the time that nodes were idle because they're unable to continue until their peers return some data. So you could have one node working away, trying to prepare data, and all the other nodes waiting for that data. An example is when a sort occurs. There could be some nodes very busy and some nodes not at all. Without recording the block time, we didn't know that some of the nodes were actually idle. So now we've recorded that, and the analyzer is providing better information. There's been a few other minor fixes to the statistics and the analyzer as well. Okay, coming to the main goal for this talk, the roadmap. I've divided the development items into 4 distinct areas: new rules, features, usability, and configurability. As you can see, you can see from the size of the different areas where my priorities are, being new rules and usability. The items of the roadmap are not set in stone. They're subject to change. We might have a great suggestion from one of you, and we think it would be beneficial to the community, so we may drop, defer, or reschedule one of the existing items to accommodate a new higher priority item. However, this gives you an idea of some of the things we're looking to implement if nothing else changes, if no ideas come through. New rules. So the power of working analyzer comes from the implementation of the rules. We're looking to extend the analyzer with as many new rules as we can. So these are some of them. Time spent on function calls and SOAP calls. We expect the time taken by function calls and SOAP calls to be fairly consistent. When there's a blip and let's say some calls take considerably longer, there could be a problem. So the analyzer could look out for these unusual response times for functions and SOAP calls. Excessive rejected rows during index reads. It would be very inefficient for lots of rows to be read through an index, but only to have most of them filtered out. So we'd like the analyzer to actually look out for situations where most of the rows are being rejected from index reads. It's possible that, for example, following the index could be changed a little and far fewer rows are rejected and the performance has increased drastically. Skewed build. Building is a slow process. Skewed builds means that this very slow billing activity is concentrated on a few nodes. It is something that is frequently overlooked, and it is something that the analyzer can look at and report on easily. There is a class of issues related to sequential operations. There are a few constructs in ECL that are sequential by nature. Choose n, project with counter, iterate, and sample. Now, if you use, for example, choose n with a particular value on a data set with a certain number of rows, it's not always clear that it's sequential. But actually, if you want n rows, for example, the first slave must return up to n rows before the second slave can continue to provide the rest of the rows, or third, and so on. So quite a sequential operation. So there's plenty of different sequential issues, sequential operations, but I won't cover that today. Distributes. One of the aims of distributes should be to reduce skew. So if the output from a distribute is actually increasing the data set skew, then there could be a problem that the developer isn't aware. Again, the analyzer is going to report on distribute skew. The analyzer could detect unbalanced joins and slow joins and suggest a more suitable join. So it's very easy it's very difficult to determine the best type of join without having access to the data, but the analyzer will be able to provide that information. Ideal cluster size to process a job. Traditional HPCC deployments on bare metal have been fixed size clusters. The users could at best select from a small number of fixed size clusters, say 16 node, 64 node, 400 node cluster. So it wasn't very difficult to decide which clusters to run the job on. You choose based on how big your data set is or how quickly you want the job to run. However, in the cloud, the sizes are becoming more flexible. So you can actually choose exact, you can say, I want 21 nodes, or I want 33 node clusters to process my job. This flexibility provides huge amounts of power and could potentially provide the optimal efficiency. The optimal cluster size for a job could be the one that completes in the shortest amount of time, one that uses the least amount of resources, or a balance of those two. It is my intention that the analyzer would be able to suggest the ideal sizes of the cluster for a particular job. So it could suggest, okay, this is the best size cluster to have this job completing in the shortest amount of time, or this is the best size job to have the job completed with the least resources. It's not always obvious, you can't just increase the size of the cluster and have jobs completed quicker. This, I think, could be quite useful and could have substantial savings when users are in the cloud environment. Okay, new features. Okay, at the moment, we provide a cost value based on the time penalty to provide a monetary cost for every issue. Now, in the cloud environment, where we know how much the resources cost, we can configure that within the system and provide the actual cost of running a particular issue. So if an issue costs an extra 10 minutes on a large cluster, then it can say, okay, this is costing you this many hundreds of dollars. So that's one of the goals. The other feature we'd like to implement is progressive analysis. So at the moment, the analysis is available once the job completes. So if if there's a problem within a job, you don't necessarily want to wait till it completes. It would be nice to have information as soon as it's available. So if there's a data skew in a data set, it'd be nice for that to be reported as soon as that could be determined from the information in the graph and the statistics. So progressive analysis could be quite useful. We've divided it into two parts because the progressive analysis after each graph execute is quite straightforward, and we feel it shouldn't impact performance. However, the one for analysis after each activity is more complicated, and we're not sure how it will impact performance, so we need to examine this more carefully. But another big area that I'm working on is usability. So it's no good having a tool that provides all this information if it's not accessible. So one of the things I'd like to do is provide better alerting. So throughout the course of a day, jobs are continuously executing one after another. It would be we'd like to avoid having to ask developers or system operators to open each and every job after it completes to determine if there are any issues. It would be better if there was some mechanism where the users or developers could be alerted to any job with high cost issues, so they can go into that issue straight away. So some of the things we've looked at, again, the designs are not final, but we'd like to log the issues into some files in a format suitable for streaming into third-party systems. So these third-party systems could prioritize, group, filter. They could email users or highlight high-cost issues. So it provides a lot of facilities so the users aren't restricted on what we provide. They can build their own system. We're also looking to enhance ECL Watch so that any jobs with issues are flagged in ECL Watch's work units tab. ECL Watch could even color code indicate the severity of each job. We're looking at a number of other improvements to ECL Watch. We'd like a clickable activity ID so that they can click the activity ID and go straight to the relevant activity in the graph here. We'd also like to put a button in ECL Watch to reanalyze the job. So if a job was analyzed with the previous version, you get the latest version of HPCC, there'll be more rules, and you may want to reanalyze a job that you're concerned about. So we'd like to provide an easy way of doing this. We'd also like to indicate within ECL Watch if the analysis shown is with the current version or with the previous older version of the analyzer. So that means you could actually immediately see if the analysis provided is current or not. And if it's not current, then you just click on the button in ECL Watch to obtain the updated analysis. With every issue, we'd also like to provide a link to a wiki page where the user can obtain more in-depth information and details about under what circumstances the issue could be caused, possibly guidance on how to resolve the issue. We've got configurability is an area that we need to work on as well. Ability to express rules. So there may be issues reported by the analyzer that has been examined by the developer and has been determined as being not a problem or not worth fixing. So we don't want those same issues to be reported again and again. So we'll be providing a mechanism to suppress specific rules for a section of code or the entire cluster. There will also be some configurability as to the reporting threshold. So if we have determined that the user wants to only see where there's SKUs greater than 125%, they'll be able to configure that. Looking further ahead, user requested features. I've received a large number of useful suggestions from users. For example, users have suggested the suppression of rules functionality, the ability to be reanalyzed within ESOWatch, and they've requested better alerting methods. So, as you've seen, we're looking to implement many of the suggestions that's been received. I would welcome and encourage feedback and suggestions from users. So this is definitely, I mean, when you're working with the platform and you're seeing issues regularly, which I may not be, I'd welcome any suggestions on things you'd like to see on in the analyzer. There may be ways you can see that we can improve the usability, configurability, connectivity. If there's anything that's holding Workunit Analyzer from becoming more useful to you, I'd like to know. So please email me or open it tomorrow, and I'll look to implement some of those. Apart from the user requested features, in the long term, I'm looking to implement this version for Roxy. We haven't done it so far because it's a completely different engine, and it requires a different set of rules. The statistics are different, the issues are going to be different, and we can't analyze Roxy in the same way. It has to be very, very fast. We don't have, we can't add an extra second to Roxy's execution time. It's likely to be well into 2021 before we begin the Roxy version. Finally, we'll continue extending the analyzer with more rules. Usefulness of the analyzer should grow rapidly with each of new rules. For your information, I examine production issues, and any issues reported in VAR should be useful. I hope you have found this update on the Workunit Analysis Tool useful. Before I end my presentation, I have one more quick poll question. Which improvement to the Workunit Analysis Tool matter to you the most? The rule set, the usability, new features, or configurability? But that's all from me. Thank you for listening. And I'd like to hand over to, I think, Jessica.
Correct. Thank you very much. All right. So, Shamser, while you take a moment and go through the questions from the audience and prioritize those, I'm going to take a quick look at your first poll. And the question there was, how useful would a post-execution Workunit analyzer be to you? And this is great news for us, I think. 62% are saying very useful, and 25% are saying useful. So that's 87% basically think this is going to be useful. 6% were not sure, and 6% said not useful, but who knows, maybe in the future. So let's go ahead and take a quick peek at the questions. And I'm going to go ahead and start with the first one here. Can you use the analyzer to compare work units from different versions of the platform to see the differences? I assume the analyzer is specific to the platform version.
Yes, you can, and no, it's not. You can compare it. You can use the analyzer to compare work units from different versions of the platform to see the differences. The analyzer is not specific to a particular platform version, at least a minor version. If there's a major version, then maybe, but all the 7 series versions will be compatible. We can pretty much guarantee that. sorry. Having said that, anything prior to 7.4 won't work with the analyzer because the information isn't available.
Okay, thank you. All right, so here's the second question. Are user-defined rules possible?
No, they're not at the moment. We're focusing on implementing, identifying potential issues and ways of identifying issues. So we haven't implemented a rule, a method to allow users to define the rules. But I would welcome users emailing me any rules that they would like implementing. Because the other benefit of me doing it is that we can gather all the different rules in one place and have everyone benefit rather than everyone doing their own rules and not benefiting as much.
Okay. It looks like we have quite a few questions coming in here. So Shamser, while you take a moment and look at the questions and prioritize those, I'm going to look at your last poll question. Right. So the last poll question was, which improvements to the Workunit Analysis Tool matter the most to you? It looks like overwhelmingly 60% have said the usability, 30% have said the rule set, and 10% have said the new features. Nobody said the configurability, but I'm sure that's still important. So, all right, Shamser, let's take a look at some of these questions that have come through. Is there a configurable threshold that we can set so the analyzer can alert for particular values of SKU?
Not particular values, but you can set a threshold beyond which it will report SKUs. If there's any specific, I'm not sure how this would be used for specific particular values of SKUs. But if this would be useful, send me an email and we can discuss it. Find out if it's very useful. I can look at implementing that in the next version. But we have to see how useful it will be.
All right. Let's see. So we've got several questions that are in the queue here. Shamser, are you okay if I ask some more?
Yeah, sure.
All right. So let's see. Great presentation. Thank you for that. Kudos to Shamser. Having been actively using the Workunit Analyzer, it's already saved me a lot of time on many graphs. I may have missed this, but are the results ordered in worst offending order?
Okay. Thank you for the feedback. First of all, the issues with there's a threshold beyond which issues won't be reported. So the least offending issue will not be reported at all. The issues are there's a cost recorded with the issue, which is not visible in ECL Watch at the moment. We're working on that, but you can use the cost to determine which one is the worst offending issue. But we don't record it in a particular order. We look at a threshold of, is this issue bad enough to record, and then we record the actual how. The cost in terms of it's recorded in the priority field at the moment. But you can't see it ordered, but you can see that it has a value assigned to how bad it is.
All right. So looking at the questions here, here's one. Is the tool included in the binary version I download?
Well, no, not at the moment. The tool is released as part of HPCC Systems packages, so that it's not released separately. No.
Okay.
Yeah, it does make use of lots of different parts of the platform code, so I can't independently release the tool.
All right. And it looks like, Shamser, we've got one last question, or we have time for one last question. And this is a multi-part question. Can we alert on memory pressure within the source slaves? The second one, which may have already been addressed, is does this work on Roxy queries? The third one is, can we suppress SKU warnings or any of the warnings on an ECL statement-by-statement basis?
Okay, good question. Can we alert on the memory pressure within source slaves? I'd need to look into this. We are actually, at the moment, just examining the work unit, statistics, and graph, and the memory information isn't recorded in there. But it's definitely something we could look into. Yeah, I don't think so. But I will look into this. The second question, does this work on Roxy queries? No, because it's completely different. There's different complications, and I think, we had a slide on this. I think you mentioned that. I've answered this. Can we suppress SKU warnings or any of the warnings on ECL statement-by-statement basis? Yes, you will be able to. It's something that I've mentioned in the configurability, and line by line, you'll be able to disable specific warnings.
Thank you so much, Shamser. And you had mentioned that you're open to feedback or suggestions, or if people have questions. Here's Shamser's contact information, his email address. So, Shamser, it's all right for people to email you? Absolutely,
yes. I'd welcome any suggestions, feedback. Yep.
All right, wonderful. And there is a blog that Shamser has written on the Workunit Analysis Tool. If you go to our website under Communities and you go to the blog, on the right-hand side, you can sort the blogs by author. If you sort by Shamser, who actually is the first person at the very top of the list, if you sort by him, you can see a blog about this, so further information is available.